Hello, this is Whitney Otan, Professor of Geology in the Department of the Earth Sciences, and today I am here to explain the second laboratory exercise in ESC 195 Natural Disasters. Today's topic is the relationship between river flooding and flood frequency. In the last video we discussed the concepts of stream discharge, the relationship between the width, depth, and velocity of the channel, and how as stream discharge increases, the elevation of the water in the river, or the stage of the river, can change. So when discharge increases, stage increases, and water rises in a stream channel. But there are a few other considerations to look at with respect to the nature of flooding as a disaster. One of the more important characteristics of a stream is what is referred to as the flood hydrograph. When a river stage rises, it will also inevitably fall, and that is the nature of the flood hydrograph. And the flood hydrograph will record a rise in water and a fall in water, which occurs over time. The shape of the flood hydrograph, how quickly it rises and how quickly it falls, is one of the fundamental characteristics of a flood. So from the flood hydrograph we can make interpretations of what geographic areas in a river valley might be susceptible to flooding, and we can also have an understanding of how often the floods may occur in a given area. How often a flood occurs is the concept of flood frequency. As you probably know, rivers do not flood all the time, and they do not flood every day. In our part of the world, we need things like severe rainstorms or protracted long-term snowmelt. Both of these are the features which typically cause flooding here in western New York. Floods can occur for other reasons, such as flash flooding in mountainous areas. We can also see flooding in association with the rise of the ocean in coastal storms. But for all of these types of events, floods will tend to have a tendency to either be frequent or infrequent. Now, when we look at the nature of the flood frequency, we are interested in a couple of things. First, for a given river, large events, big floods, typically occur rarely, or they occur infrequently. Smaller floods tend to be more common and occur more often. So in general, the larger a flood event in a river, the less frequently the flood occurs. Now, we also look at the level of the flood magnitude. How high did the water get in a given flood? And magnitude is inversely proportional to frequency. What we mean here is that big events occur rarely and small events may occur often. So small events may not be nearly as catastrophic as big events, but they can be problematic in their own right. One of the things we try to do in understanding flood risk is conducting statistical analysis on the history of events. So when we look at a river and we understand that a given river stage will occur once every so many years. So for example, the river may rise 2 feet above bank full once every 10 years. It may rise 10 feet above bank full once every 100 years, and higher elevations of water would be even less frequent. This is the concept of flood recurrence. Recurrence is the concept of, on average, how often does an event occur? Does an event occur once a year, once every 10 years, or once every 100 years? Now, there's no guaranteed absolute that an event will occur once a year if the probability or the frequency is once a year, but these are statistical estimates, and these statistical estimates are conducted by probability analysis. So one of the things that is important to remember when we're looking at the nature of a flood recurrence, when we say a river stage rises on average once every 10 years, that means that there is 10% chance of this occurring every year. In a contrasting example, in a rarer event, if a flood rises to a 100-year level, there's a 1% chance of reaching that level every year. So think of it in terms of analogous to throwing die or drawing cards, okay, in a card game. If I were to pick randomly a card from a deck, the chances of drawing the ace of spades would be 1 chance out of 52 cards. So by comparison, a flood of a given magnitude would have 1 chance in 100 years of reaching its 100-year flood level. This would be the relationship of the flood recurrence. The chance of this probability does not change from year to year. It's important to remember that if a 1% event or a 100-year flood occurs, this certainly does not mean that we can rest our laurels and wait another 100 years to expect a flood. We have a 1% chance of having the same event the next year, the year after, and the year after that. So the ability to predict flood frequency helps us understand how likely we are to experience problems in association with flooding, and as a result, what risks would we be at for activities in a floodplain. So we utilize these recurrence intervals in order to estimate this chance of risk, and we also do this in order to make determinations of what sort of activity should be occurring in a floodplain. So, for example, if a parcel of land is likely to overflow or flood every year or every 2 years, it would be problematic to expect to live at that position in the floodplain and not expect floodwater to come onto your property. So as a result, we can utilize techniques in mitigation to work around the flood problems. So for example, we might want to elevate a structure above the expected flood level, or we may wish to conduct activities that do not produce economic damages or harm when we are involved in doing something in a position in a floodplain, which would be considered to have a high probability of flooding. So with that explanation, hopefully you'll enjoy your exercise this week. Look at the relationship of flood frequency and flood risk. They are important concepts, and they are the basic information we use to make estimates of what problems we may encounter when we have activities in flood-prone areas. Thank you very much for your attention. Signing off now. This is Whitney Otan. Have a good day.